So these are the hidden state students. These are the observed models. Okay. So we'll be having the access to only these observed variables. We don't have access to the hidden states. Okay. So based on this observed model, we need to predict what are the hidden states. Okay. So here, this is the Markov model is given. So here, what is that we have? This is the transition. Uh, this is the transition model, and this relation we have no, this relation that is called this is the relation we have no. This is called what is that um, observed model or sensor model. Okay, so whenever we are drawing hidden Markov model, we will be having two models, that is transition model and observed model or sensor model. Okay, so what is that here? This is the transition model. Okay, and what is the observed model? The relation of this observed state with the is called observed model. This is the one observed model. This is the other observed model. This gives you the observed model. The other one gives you the transition model. Okay. Now from this table, we are just writing this matrix. What is this? This is called transition matrix, and this is called observation matrix, or it is also called emission matrix. Okay. So this we have discussed. No? On this, okay, whether it is rainy today, tomorrow's weather is also rainy, it's given as 0.5. Whether it is rainy, tomorrow's weather is foggy, it is given as 0.3. Okay, whether is rainy, tomorrow's weather is given as sunny, so it is given as 0.2 here. Weather is foggy, tomorrow's weather is given as what? 0.4. So if it is foggy today, tomorrow also foggy, it is given as 0.2. So here it is 0.2. Weather is foggy, tomorrow's weather is sunny, it is given as 0.4. So here also it is given as 0.4. And today's weather is sunny, sunny, and tomorrow's weather is rainy. It is not given, no? Its probability is 0. Okay, so today's weather is sunny. Tomorrow's weather is foggy. It is given as 0.3. Today's weather is sunny. Tomorrow's weather is also sunny. It is given as 0.7. So this is the transition matrix we are getting from this transition model. Okay, and this are the person is sad based on this weather conditions. So what are the weather conditions you see here? Foggy, rainy, foggy, sunny. These are the weather conditions. Rainy, foggy, sunny. So when this person will be sad, so for this weather conditions, it is given as 0.9, 0.6, 0.2. So 0.9, 0.6, 0.2. The person will be happy for the weather conditions, and its probabilities are given as 0.1, 0.2, 0.8. So it is given as 0.1, 0.8. Okay. So this is the transition matrix, and this is called emission matrix. Now we want to know the person is happy, happy, and sad, such that the weather conditions, what are the weather conditions? Sunny, foggy, sunny. Okay. So for these weather conditions, the person mood is happy, happy, sad. What is the probability of having these sequence of observed variables given the these are the weather conditions? Okay. So which probability? So how do you find out this probability? We are using, see here, whenever we are finding conditional probability, you have to consider three parameters. What is that? We have to find out what is the probability of initial state and probability of product of transition matrix and the emission model. Okay. So here, what is the initial statement? The probability of initial state is what? This is the state and these are the evidence. Okay, so the initial state is that sunny. The probability of y1, the y1 is this. Okay, that is happy given that sunny, and the x2, the transition from the initial state to the next state, that is What is that? Here it is changing from sunny to foggy. So what is the probability of getting foggy such that yesterday's weather is sunny? And what is the probability of happy such that today's weather is foggy? Okay. And what is the probability of transition from foggy to sunny? So it is the probability from transition from foggy to sunny. And what is the probability of sad given that today's weather is sunny? Okay. So this equation we have discussed. No, this one will be expanded by using this equation. Okay. So this equation, and we know all these values. What is the probability of happy given that today is sunny? Happy and sunny, what is the value? 0.8. Okay, so happy and sunny is value is 0.8. The transition from X to foggy, sunny to foggy, the value is 0.3. And what is that? Happy and foggy, is 0.4. Okay, and what is that? Here we are finding the transition from foggy to sunny. Foggy to sunny, the value is 0.4, and the transition from Y3, sad, such that the weather is sunny, the value is 0.2. Okay, these values we got from these two tables. Okay, now we need to find out what is the first value. To find out first value, we are using eigenvectors. Okay, so if we are using eigenvectors, so what is that here? You see, this is rainy, foggy, sunny. So the first eigenvector will give you the probability of rainy. The second eigenvector will give you the probability of foggy. The third eigenvector gives us the probability of sunny. So what is that? First we want the probability of sunny. So what is the probability of sunny? It is given as 0.509. So substitute 0.509, and if you just find the product of all these values, okay, if you find out product of all these values, we'll be getting the probability of getting this particular observed sequence such that this is the weather sequence. Okay, so we are just substituting that value and we are just finding the product of all these values. So what is the value we are getting? The probability of having this output sequence such that the weather sequence is this is given as 0.001.